Hi, Brandon.
Hello, Brandon.
We're starting. We collected, went over the homework and collected it, and now we are looking at Chapter 3, Day 3. See, we have a new handout. There it is.
Oh.
For my Disney videos.
Wait, what am I? Should I just like show him the whole thing?
Of everyone.
Hey, Brandon.
Did you finish them?
No. But thinking about it makes me really want to. But I'm not going to be able to.
Okay.
I can.
I can just picture him right now. He's just like,
Wait, what should I? Wait, should I just show him this paper? Like,
Yeah, just show him. That's
Every
it.
single second.
Just show him. Linear
lots
data.
of
The end. Bye,
things
Brandon.
on
Are you
it.
gonna keep all of this stuff in there? Or are you cutting out some?
I mean, I'm going to try to make them as short as I can. But
Okay,
All right,
that's into that, and then the back is looks like this.
Yeah.
We're looking at Day 3, and we're going to look at data today. We're going to take data that is linear in nature. So let's look at linear. When I say the word linear, I am very liberal about that. So it's linear in nature. So we're going to look at data that's linear on the scatter plot. And that's what we were kind of looking at yesterday. There might have been a curved pattern pop up, but we're in linear land today. So linear data. And the first set of information there where it says NEA, find that, the chart that says NEA.
That's right here.
NEA stands for non-exercise non-exercise activity. So, we're talking about not a planned walk around the neighborhood or a planned jog. We're talking about exercise that is, activity that is non-exercise. Can you think of anything we do that's not a planned exercise workout, but it is activity?
Getting up out of bed in the
All
morning.
right. So just daily moving, daily motion. And
Hugging.
there's something else. Talking, did you
playing with
say?
children and having to pick them up.
What?
Playing with children and having to pick them
Playing,
up.
alright. So like daily motion. The
Dancing.
what?
Dancing.
Dancing.
Your normal bodily functions.
Yeah, normally bodily functions,
I hate that
motions, body functions, take calories, right? But the other thing, Elena was alluding to it, it's not quite dancing, because that's almost like a planned activity, unless
No.
you dance
No,
around
like
a lot.
dance.
But
No, we
No.
do dance around.
Yeah. I don't plan
Just the
on
other day, we were dancing in the middle of Applebee's.
dancing in the moonlight.
Oh.
this is the thing, we're really zeroing in on NEA.
Fidgeting.
Right.
Oh, what a great thing.
What?
All right. So the main thing, we're talking about regular, everyday calorie use, just walking around doing your normal stuff.
Fidgeting, we're burning
But a
calories.
lot of people, fidgeting burns, this is what this is studying, so we're not sure. So what we're looking at is this chart of data. So the NEA change in calories is for non-exercise activity like fidgeting, and they're comparing that to fat gain. So what they did in this example is they charted it for us. So I would normally ask you to make the scatter plot, but to save time, look at
Look,
the
they made
scatter
it for
plot
us.
below the data. What
Data.
we're looking
This
at
is the
here,
scatter
let me
plot.
explain. You may take some notes around the data so you can understand it better when you look back. And that is these people, this is sad, they took 16 healthy young adults and for 8 weeks they overfed them.
Oh my God. That sounds. Can I be part of the study?
Go right ahead, just keep me out of it. So notice what happens when they graph the data. They're looking at non-exercise activity along the explanatory x-axis, and they're looking at the fat gain. This is for you're expected to be, if you're overfed for 8 weeks, you're expecting quite a bit of fat gain. But what happens here when we look at as NEA goes up, what happens to fat gain?
It goes down.
It goes down, right. So what we're going to do today here is the data went like this, it went down. We're gonna add a line today. And I think I had you do a line the day that we were doing the search for the missing cookie. So if you would, again, we're gonna add a line, and you can see on the scatter plot, the book already added the line for you. We're gonna give that line a special name, and it's called regression line.
Your
So-
name is special.
The regression line is when there's an explanatory variable and a response variable. And we will take a line and we will put it as close to the middle of the points as possible. So just as many points are above the line as below the line. So did they do a pretty good job of fitting that line in the data? Looks like it. Looks like about the same above as below. So this line is showing how the Y response changes for change in the explanatory variable. So let's give the regression line a name.
Have we been timing this?
Yeah, we haven't. So what do you say, 5 minutes so far?
I think it's probably been 10 minutes.
Really?
Actually, I don't know.
I have no idea.
It seems like
It
it should
feels
have
like
been
it's
10.
been a lot of time.
Yeah.
All I did was,
It doesn't feel like it's been a lot of time, but it always ends up being
Yeah,
more
all
time than
right.
it feels
Well,
like.
whatever you think, Bailey. Just maybe in 5 minutes, just turn it off. Say the worst case I'd say was 10, and I want to stay under 15. All right. So we're going to give this line a mathematical name now, and it looks like this. Please take notes on it. It's a Y with a little hat on it. Guess how we read
Y
it?
hat.
Y hat.
We did that already.
Cool. So Y hat equals A plus B.
Wait, we don't. I have
X.
Jason.
All right, that's going to be the name of our regression line because all our lines are straight. You'll notice it's linear. And I'll tell you what each of the pieces are. Please take notes as I explain. This is called the predicted value. The predicted value is Y hat. I'm sorry, this is going to upset my mathematical soul. A is the Y-intercept. Why does that upset me?
It's supposed to not be. It's supposed to be B.
Whereas we're used to Y equals mx plus b, but the statisticians, of course, and your calculator maker have changed the Y-intercept to A. So thanks a lot.
Thanks a lot.
All right, so guess B is
Thanks,
now the
Obama.
slope. So that's, I'm sorry to mess you up with that. So the slope is the change in Y for each change in X. So we'll talk about that on an example. And this is, when I say predicted value, I should say for the response variable.
Oh, I missed simple algebra where you just had to find the slope and the y-intercept.
I don't even remember that.
I only remember it because I have a teacher.
And the X's values for the explanatory variable.
Yeah, with the X. I didn't have to find it. It was something.
So Y hat equals A plus BX. So you have to switch out of B being the Y-intercept. It is the slope now in Statland. So for this particular example where we have the non-exercise activity down here in calories, and up here we had the fat gain in kilograms. So the particular example we have looks like this.
What's a kilogram?
Strange, but we get phone calls in here, but, all right. So can you find the example? They actually gave you the slope and the y-intercept for this example. Julia, could you read that for us?
Sure.
It starts with the word fat gain hat.
Oh, then it is 3.505
Right,
minus 0.00344.
times
Sounds MEH.
Alright, so you see, they have taken this equation and given you the actual numbers. They're looking for the expected value in as far as fat gain is over the 8 weeks. Then you have the A value, B, the X value. So you can see appropriately by their position what they are. So let's discuss that. It says identify the slope and y-intercept of the regression line.
I don't
So
understand why they use that for the y-intercept.
I know, I knew it would upset you, it upset me.
Yeah,
I know.
and they use B in the equation.
Yeah,
Yeah.
and that makes it even worse. And when we go to our calculator, it's like this. So the calculators are against us too. Alright.
Rolls against us.
Can we change
we're all-
it?
Alright, so with this awful change, can you identify, Bailey, the slope in this equation? It's gonna be tough.
Okay. Just like estimate it?
No,
give it to you.
no, I'm talking about looking at the equation that Julia just read
Oh,
and telling me
negative.
exactly what the slope is.
negative 0.00344.
Right. Yeah, there's no way we could get that very clearly from the looking at that line.
How is the y-intercept 3.505 when the line goes above 4?
It's
It's when it hits 0.
the 0 line was drawn in below
Yeah, look
to
at 0.
answer that.
Oh,
Yeah, I thought the same thing, so I put it in
Okay.
below.
okay.
All right, so Bailey said this was the slope, and what I'm going to train you now is that all-inclusive word interpret.
Bye.